So, what is electricity? Think about it for a moment. It's all around us, but we can't see it. This invisible force is a type of energy. Specifically, it's the flow of tiny, tiny particles called electrons. Everything in the universe is made of atoms, and atoms have these electrons buzzing around them. When we get a whole bunch of these electrons to move together in the same direction, like a river of super small particles, we get an electric current. It's this movement, this flow of energy that we call electricity. It's not magic, it's science, and it's one of the most powerful forces we have learned to use. Imagine you have a long line of dominoes all set up. When you push the first domino, it falls and pushes the next one, which pushes the next one, and so on. A wave of energy travels down the line, but each domino only moves a tiny bit. Electricity works in a similar way. The electrons don't travel all the way from the power plant to your lamp. Instead, they just nudge the electrons next to them. This creates a chain reaction that sends energy flowing through the wire almost instantly. This is why when you flip a switch, the light turns on right away, even if the power plant is many miles away from your home. Let's break it down even more. Think about static electricity. Have you ever rubbed a balloon on your hair and watched your hair stand up? That happens because you are rubbing electrons off your hair and onto the balloon. Your hair now has a positive charge and the balloon has a negative charge. They attract each other. This is a simple form of electricity at rest. The electricity that powers our homes is called current electricity because the electrons are constantly moving or flowing. This continuous flow is what makes it so incredibly useful for running all our gadgets and gizmos. Understanding this fundamental concept is the first step to appreciating the world of electronics and power. It's the movement of these incredibly small particles that allows us to light up our cities, communicate across the globe, and explore the universe. From the lightning that flashes in a storm cloud to the smartphone in your pocket, the principle is the same. Electrons are on the move. This flow of energy is a basic law of physics, and by understanding it, we can build amazing things. Science rules. So, if electricity is moving electrons, where do we get it from? We can't just grab a bucket and scoop it out of a river. We have to generate it, which is a sciencey way of saying we have to make it. Most of our electricity is made in big buildings called power plants. Inside these power plants, we use a clever device called a generator. A generator is basically a machine that uses a giant magnet spinning inside a huge coil of copper wire. As the magnet spins, its magnetic field pushes and pulls the electrons in the wire, forcing them to start moving. And what do we call moving electrons? That's right, electricity. Now the big question is, what makes the magnet spin? We need a source of energy to turn it. This is where different types of power plants come in. Many plants burn fuel like coal, oil, or natural gas to heat water and turn it into steam. This high-pressure steam is then used to spin a large fan-like object called a turbine. The turbine is connected to the generator, so when the turbine spins, the generator's magnet spins too, and voila, we are generating electricity. This method has been used for over 100 years to create large amounts of power for our cities and towns. But burning fossil fuels can create pollution, which is not great for our planet. So, scientists and engineers have found other, cleaner ways to spin those turbines. In a hydroelectric power plant, we use the force of falling water from a dam to turn the turbine. In a wind farm, we use the power of the wind to spin giant windmill blades, which are connected to a turbine. And in a nuclear power plant, we use the heat created from splitting atoms, a process called nuclear fission, to make steam and spin the turbine. All these different methods have the same goal, to create motion to spin a generator. We can even get electricity directly from the sun using solar panels. Solar panels work a bit differently. They don't use a generator. Instead, they are made of special materials, like silicon, that can absorb sunlight and knock electrons loose directly. This creates an electric current without any spinning parts at all. As we look to the future, finding clean, safe, and renewable ways to generate electricity is one of the biggest and most exciting challenges for science and engineering. It's all about finding clever ways to get those electrons moving. Once we generate electricity at a power plant, we need to get it to our homes, schools, and businesses. This is a huge job. The electricity has to travel, sometimes for hundreds of miles, to reach its destination. This journey happens through a complex network of wires called the power grid. Think of it as a giant system of highways for electricity. The grid connects all the power plants to all the places that need power. It's an incredible feat of engineering that keeps our modern world running smoothly day and night through sunshine and storms. The first step in this journey involves a device called a transformer. The electricity that comes out of the generator has a lot of current but not enough push or voltage to travel long distances efficiently. So, a step-up transformer at the power plant increases the voltage way up high. Pushing electricity at very high voltages is like sending water through a very wide pipe under high pressure. It loses less energy along the way. These high-voltage power lines are the really big ones you see strung between giant metal towers that march across the countryside. They are carrying a tremendous amount of electrical energy. As the electricity gets closer to your neighborhood, its journey is not over yet. The super high voltage that is great for long-distance travel is way too dangerous to bring directly into our homes. So, the electricity goes to a smaller station called a substation. At the substation, a step-down transformer does the opposite of the first one. It lowers the voltage to a much safer level. From the substation, smaller power lines, the ones you see running along your street on wooden poles, carry this lower voltage electricity into your neighborhood, bringing it one step closer to your front door. The very last part of the journey happens right outside your house. There is often another smaller step-down transformer, which might be a gray can on a nearby utility pole or a green box on the ground. This transformer lowers the voltage one last time to the level that is safe for your appliances. From there, a final wire runs from the pole to your house and connects to an electric meter, which measures how much electricity you use. Then, the wires go into the walls of your house, ready and waiting for you to flip a switch and complete the circuit. It's quite a trip for those little electrons. Think about your morning. An electric alarm clock probably woke you up. You flipped a switch and an electric light filled your room. You might have toasted a slice of bread in an electric toaster and grabbed some milk from an electric refrigerator. Before you even left for school or work, you probably used electricity a dozen times without even thinking about it. Electricity is like an invisible helper that works for us all day, every day. It powers the tools that entertain us, the machines that keep us comfortable, and the devices that help us learn and communicate with each other. Let's consider all the different jobs electricity does for us. It creates light with light bulbs, and it creates heat in things like ovens, hair dryers, and water heaters. It creates motion in the motors of fans, blenders, and washing machines. It also powers all of our electronics, which is where things get really cool. Your computer, television, and smartphone all use electricity to process information, create images on a screen, and produce sound. These devices use intricate circuits to control the flow of electricity in very precise ways, allowing us to do amazing things like watch movies, play games, and talk to people on the other side of the world. The importance of electricity becomes crystal clear when the power goes out. Suddenly, the lights don't work, the refrigerator stops humming, and the internet is gone. Our homes become dark and quiet, and we quickly realize how much we depend on this steady flow of energy. It shows us that electricity isn't just a convenience. It's a vital part of our modern infrastructure. It keeps our food fresh, our homes warm in the winter and cool in the summer, and our hospitals running. It is the backbone of our society, powering everything from traffic lights to factories. So, to sum it all up, electricity is the flow of electrons. We generate it in power plants by spinning magnets in coils of wire, using energy from sources like burning fuel, falling water, or the sun. This electricity then travels across the power grid through a series of transformers and wires to safely reach our homes. Understanding these basic ideas is important because electricity is so deeply woven into our lives. The more we understand it, the better we can use it safely and efficiently, and the more we can contribute to finding new and better ways to power our future. Now that's some powerful science.